Hi, I'm Norman Swan from the ABC's Health Report. When Massimo Damiani was struck down by a mystery disease around his first birthday, his parents took on a seemingly impossible quest to find the cause of their son's illness. Despite their lack of scientific training, Stephen and Sally Damiani shocked the medical establishment by cracking their son's genetic code and diagnosing a new disease. In the 4 years since Australian Story documented their astonishing discovery, the Damianis have been working towards a treatment that could have benefits far beyond their little boy.
I was a chartered quantity surveyor once upon a time. I, at the time, thought genes were things that you wore. I had no idea. It's the ongoing joke with all of this is that I failed a Year 11 chemistry midterm and I ended up being published as one of the authors of this paper in the American Journal of Human Genetics.
For centuries now, lay scientists have made advances ahead of the people who are paid to be scientists. And this is just yet another example through history of where lay people using their brains are able to make discoveries.
Hey, Marco.
Oh, hi, Stephen.
Hey, how is it? I don't think I'd ever come across a parent quite as driven to find the cause of its child's disease.
Going on a crawling mission? Hello.
And I couldn't look in the mirror without knowing that we'd done everything that the science could let us achieve.
We just wanted the best for our baby. There was never a scenario where we wouldn't get an answer. We didn't necessarily know how long it would take, but there was never a scenario where there was no answer. Like, it was never something that we were going to accept.
In the beginning, it was all about Mo and giving him the best possible life.
Oh, good boy.
Massimo obviously couldn't walk, talk, so he needed, you know, one-on-one care all the time, and that just becomes your whole world.
Good boy.
Step, lift, step. Okay, move.
But it's just moved so much past that now. Massimo changed the world. He changed science. Stephen and Sally. And they did what so many people said could never be done. And that will live on forever.
When you have your first child, you're overjoyed. It's this fragile, beautiful little thing. You've just got all these hopes and dreams. And we had a beautiful first year.
Massimo developed like any other kid. Rolled when the book said he would roll. Started crawling when the book said he would start crawling. Pulled up to stand. You know, just did all the things kids do. He was a really happy child.
But then we noticed that something wasn't quite right with Massimo. He was clenching his fists, his toes were pointing down, you could see his toes were curling when he was cruising around the table. He would be throwing his head back for no reason.
Good boy. What the?
I remember he crawled up to the coffee table and we had all his toys out. He crawled up, put his hands up, and he couldn't get up.
Oh, his muscles gone. Come on up. Yeah, muscle. Up we get. Yeah, he used to be able to 2 weeks ago.
The first couple times it happened, you were like, okay, don't overreact, don't be one of those parents. It'll be fine, I'm sure it's just a one-off thing. And then you kind of go, no, this is a thing now.
Poor little man.
We saw the physio at the children's and we quickly found ourselves going through for an emergency MRI. The faces of everyone in recovery at about 2 a.m. were just grim, and you could just read something terrible had gone wrong that night.
The white matter areas here would be much darker than we see on the picture. Once the scan was done, it was pretty clear he had a leukodystrophy. Nerve fibres, they're not happy, they're sick. I mean, they probably don't have the right amount of insulation around them.
Whilst Massimo was diagnosed with a leukodystrophy, that's just an umbrella term like saying cancer, but we didn't know what type of leukodystrophy he had.
Massimo will unfortunately need quite a few tests to try and work out what's caused this. Our brains are a bit like electrical machines, and there are wires connecting up the nerve cells to the body, and those wires are covered by an insulation, just like electrical wires are covered by plastic. So leukodystrophies are disorders of that coating or insulation around the nerve fibres.
When you have a form of leukodystrophy, it will start breaking down your body's ability to transmit signals from the brain to your body. And that's why Massimo started to lose skills. They're degenerative conditions where patients will be robbed of their eyesight and eventually all of their senses until death.
Hello, Yuko. Come on.
Those initial months, he regressed very, very quickly.
Crawl.
I was working as a respite carer, and my manager came to me and said, "We've got a new baby on the books," but she said, "Don't get attached because in 3 months they're expecting him to be either in palliative care or gone."
I mean, the worst part was we could see the fear on his face when he'd try and sit up and he'd fall over straight away. We would see the frustration when he would, find the edge of the coffee table or the couch and try and pull himself to stand, and he couldn't do it.
Massimo, what's that?
He knew something was wrong. He was looking at us. You could just see in his eyes, like, what's happening to me? Help me. And it was just, we felt so helpless.
My man, will sit down and pop your AFOs on.
We tested for all of the known forms of leukodystrophy and all of the results came back negative. We knew it was likely genetic, but we didn't know what the gene was that was causing this particular condition.
Good job. I'm going to carry you out to the car, all right?
We needed to work out a way to identify the specific gene.
You ready to go?
Mike, ready to go? Yep.
Because without a genetic diagnosis, you've got no option to access any form of treatment, even a clinical trial. Not having a diagnosis really had a deep impact on all of us, but especially me. I just could not cope with not knowing what was causing his illness. I certainly wasn't coping well with the fact that I may lose my son.
So they are pretty stiff. He's just had the Botox recently, hasn't he?
Yeah, just last week.
So we've made him the promise that we're going to do our best to try and come up with a treatment. Maybe not necessarily to cure Massimo, but certainly to make him better.
Stephen and I, we'd just read anything we could get our hands on to understand what we're dealing with. Neither of us have medical training. Yes, there was a genetics for dummies book read.
He was just spending hours and days and months to do his own research and really become an expert, to be able to hold a conversation with any researcher in the field and know what he was talking about.
Stephen just kept saying to me, they've sequenced the whole human genome. If they think this condition's genetic, well, we'll just get his whole genome sequenced. And he's saying that from the very beginning. I
was searching for whole genome sequencing back in 2009, 2010, and it was really just unheard of. Eventually, a company came up in the United States.
Yes.
I remember the call well, speaking to someone saying, I'd like to order my son's genome. And it was met with a, you'd want to order what? Because no one had ordered this at the time. It was really, bleeding edge stuff. And anyway, a few phone calls later, a few meetings later, a sample of Massimo's blood was on its way to the United States. So this is all the data that came back, comparing Massimo's genome to a baseline genome. But eventually the data came back, which had 11,500 variations across 5,700 genes, which was clearly a number that was too great to be meaningful to narrow down the diagnosis. And it was at this point that I thought we would also need to sequence my genome and my wife's. We might be able to pinpoint the exact variant that's causing Massimo's condition.
If you've got a child with a rare disease and you do the analysis of their genome and you see all these variations, which is the one that's caused the disease? Now, they've got all their genes from their parents. So if you actually examine the parent's DNA and compare that to the child, it helps you find the needle in the haystack.
Which may be billions of combinations, but to try and pinpoint, to me it was this simple maths problem. You run some complex differential algorithms on a big computer and out pops your answer. How hard can it be? I soon found out it was a little more difficult than that. The missing piece of the puzzle was finding someone that was both willing and able to perform such an analysis.
We weren't expecting Massimo to have a really long life expectancy. The one thing we were 100% certain about was that we wanted him to have siblings and we wanted them to meet. There was a lot of things that were confusing at the time, but that was our one, moment of clarity.
There was a greater chance that Massimo's condition was passed down maternally. So we concluded the lowest risk option was to move forward with an egg donor.
It was quite funny because when the twins were first born, Massimo became very jealous all of a sudden, which was kind of funny to watch. It was good because I think that helped draw him out of his shell a little bit more and kind of force that independence, which was nice.
He almost started to get a little bit better, that he started to regain some of his skills, which was quite remarkable because that's not consistent with the leukodystrophy.
That seemed to shift the focus from having brought a child home and starting the grieving process to the strongest determination I have ever seen. Stephen was trawling the internet, reaching out around the world, coming excitedly to see me with reams of research papers.
Okay, what's this genetic diagnosis by whole?
A lot of people around the world that he'd been contacting, I think, the message, take-home message was, another maverick scientist, another, backyard geneticist.
If you imagine that what we're trying to do.
And I guess I have to put up my hand as being, if I'm honest with myself, of being the biggest sceptic initially.
Step 2 is to get Sally's genome.
Our GP, and she said, how's it going with all the stuff you guys are working on? Yeah. And I was like, still trying to find someone. What do you need again? I'm like, someone that can read genomes. Oh, okay. Oh, well, I had coffee with this lady. I think her husband does that sort of work. Do you want me to introduce you?
Fascinating would be putting it mildly.
Leah introduced us to a guy by the name of Ryan Taft. That to us was a miracle. We had banged our head against the wall all over the world to try and find someone, and that someone was here in our backyard in Brisbane.
I had never worked in human genetics. All of my background was in evolutionary biology and basic gene functioning. I had never done anything in human disease genetics at all. Within 5 minutes, it was clear that Stephen's intent was, here's somebody who seems to know how to manage this data. Maybe he'll take a crack at it. I thought our chances were pretty slim, to be honest. But when somebody's on the phone with you and says, could you try and help my sick child? Very few people are going to say no.
When he came back and said, I'd like to give this a go, we knew we'd found that 1 in a million person.
Ryan was doing this in his own time, so this wasn't his day job. He sacrificed basically his evenings and his weekends. He'd just be locked away in his study, writing codes and trying to work things out.
So cutting through that data, making sense of all of that variation in his genome was incredibly challenging. It was rabbit hole after rabbit hole after rabbit hole until we started to really understand how the genome could talk to us. What we found was 2 variations in his genome that mapped to a gene that nobody had associated with human disease before.
My genome up here, and this is Sally's genome down here. These are both the reference genomes. Where there should be a C, as in the reference genome, I have an A, and where there should be a G in the reference genome, Sally has an A.
And so our big problem was, how do we know definitively that those are what's causing Massimo's illness? And what we needed was patient number 2. And And eventually, through a collaboration with a bunch of clinicians globally that Stephen had set up, we actually identified patient number 2. And it was that day that we knew we had a definitive diagnosis. As soon as we knew we had a second patient with mutations in the same gene that had a very similar clinical presentation, that's when we knew. I literally jumped up and down. I will never forget that. That was an amazing moment.
And that was the moment. That was 1,161 days after that first MRI. We discovered a completely new disease, and they called it HBSL for short, which is hypermyelination with brainstem involvement, spinal cord involvement, and leg spasticity. Yeah, I guess neurologists aren't good marketers, are they?
Okay, my man. Have a good day.
Massimo was the first child in the world to have a new disease identified due to a new gene using this technique called trio genome sequencing.
We felt very empowered having this diagnosis. Now we had an own enemy. The most immediate impact was that Massimo didn't have to undergo any more tests. So no more blood tests, no more MRIs, no more biopsies. It all stopped. And even his neurologist, Rick, said, he goes, "Oh, he's smiling at me for once." Very different. You know, it's life-changing.
Hi. We've got a visitor.
Before Massimo's diagnosis, I became a pseudo-doctor scientist, and my role as a father came second to that.
Do you want to have a little reward in here, Mo?
It's something I regret. Once we achieved that milestone, the shift went from being the scientist doctor dad to being the dad.
Your favourite song, huh?
I could certainly focus more on Massimo's quality of life and enjoying Massimo. Because I felt for 3.5 years, I missed some of that time.
Training for the Junior Olympics.
Stephen got this treadmill and put his bike on the treadmill with blocks and had a little TV so he could watch his Wiggles, which was his favourite thing in the world. It always freaked me out when he would try and modify something, but he always did his research beforehand, and it always worked.
We're going backwards.
As Massimo grew older, I think we got really quite good at managing his condition, managing all the different treatments and keeping him as happy and as comfortable as he could be. He was, you know, despite his challenges, actually quite healthy. He started school. I remember the first time we popped him on the bus to go to school. I was a complete and utter mess. But we knew he was happy. They gave Massimo a sense of independence outside of the house. He'd come home with a big smile on his face.
They actually live in the incubator.
In the incubator, they come through.
They come out and then they get exposed.
The next step for us was to get started on a treatment.
That led to an interaction with Professor Ernst Wolvetang at the University of Queensland, who has this amazing technology that allows him to create stem cells from patients.
Now, the cool thing about the stem cell is that it can make every cell type of the human body. So you can actually start to make human brain cells in the dish.
Morning, guys.
Using a sample of Massimo's skin, Ernst was essentially able to create Massimo's neurons.
Some stem cells to start with and then some neurons. Right, this is the AT cells.
Essentially, we're growing his brain. And I've seen Massimo's neurons growing in a petri dish. After a few days, you can see that they look really, really sick.
In this case, seeing bad brain cells actually made us pretty happy because we knew that we had a disease in a dish.
These are dead cells that have detached themselves from the colony.
So that's the eureka moment when you know you're onto something.
These are the exercises that are activated in Massimo, right?
Right.
And just spawning new neurons on the top and then making the top cortical layers over there.
Yeah, that's interesting.
So now starting to develop ways and treatments that can improve their function.
He's had some great success using an amino acid to ameliorate the condition.
And one of the things that we have found is that they die less, they hook up better, they make longer extensions, and it looks like it also improves the ability to insulate those nerves. So that's very encouraging.
We've got 3 elements to our research. University of Queensland, and we've got stem cells. At Walter and Eliza Hall, they're developing the mouse model. Then at the University of New South Wales, they're developing the gene therapy.
This is the Stephen mouse. It carries Stephen's mutation of the gene. So the Stephen mouse was created using cutting-edge DNA editing technology. The Sally mouse was created the same way.
When we breed those two together, then we'll have the Massimo mouse, which is an exact model of the disease. It's Massimo in a mouse.
So gene therapy aims at replacing a mutated, non-functional gene with a functional, healthy version of that gene.
With each of these research projects, it's literally grassroots fundraising.
These are like top-notch researchers, and our fear has always been we'd lose them.
Myelin basic protein deposition.
Yep.
We need to look at that.
Yep.
It's a bit beyond fun runs. I think we do need a sizable grant to really make an impact in the next 3 years.
That's the next chapter. To me, I thought there was always going to be the next chapter of fixing the code for Massimo. It takes time to develop these protocols and the technology, and I thought we had time to do that.
You like it?
We are quite often would think about the future. What do we need to make sure Massimo is well cared for? Because he will most likely survive us. We started renovating our family home to ensure it was somewhere where he could grow up into, becoming an adult.
In December, he was the best he's ever been. He was, the normal, happy, healthy Massimo.
He was having a really, really good month. At his school concert, and Massimo's class did a kind of modified version of the Hokey Pokey with a bit of a Christmas theme, and he smiled the entire way through it. I remember showing him the video that I took. He gave me one of his amazing cuddles that he does.
I remember he sort of crawled up to me and put his head on my knee, looking tired, and said to him, "Oh, it's time for bed," and sort of nodded. I picked him up and took him into his bed and said, "Good night, Massimo," and I walked out.
I guess, like any other morning, we're up nice and early. We'd often go into his room and start the process of waking him up, and Mr. Sleepyhead, still asleep, and Stephen said, "Oh, he looks really still." We turned him over, but he was gone. And it was the last thing we ever expected to happen. So it took us all by surprise.
The first person I called when Massimo passed away that morning, I just felt like I had to ring Ryan.
And I was incredibly touched by that. Stephen and Sally have become like family to me. And so to lose him unexpectedly was difficult. But it's also a reminder. We have much more to do.
At this stage, honestly, we don't know what was the cause of Massimo's death. We know that his disease affected areas of his brain that controlled his heart rate and his breathing and his blood pressure. I would just have to assume that in some way the disease had caused him to either stop breathing or for his heart to either stop during his sleep.
Thank you. This is an amazing campus.
Ryan's now working for the company that helped with sequencing Massimo's genome.
Massimo had a short life, too short.
Ryan told us about the plan to honour Massimo's legacy, which was to dedicate the clinical genomics laboratory to Massimo.
But no matter where he is right now, we all know that he'll be forever watching over this laboratory and every genome with its unique story of hope. Thank you.
The journey started there. Massimo's genome was sequenced in that lab. We wanted Stephen and Sally to know how much this journey meant to all of us and what it means for the future of providing diagnoses for children like this.
So let's have a look at these cells. It's been a while since you've been here, Steve. You'll be amazed.
Thank you.
These are the little mini brains that we have made.
It's his way of telling us in a different way to finish the mission.
Okay, well, let's see what he tells you.
Viewing these micro brains today from Massimo's cells now that he's no longer with us, it's very hard to describe. It felt right, it felt good, it felt like we're making progress, it felt like we're continuing on the mission that, Massimo wants us to finish. I feel like it's Massimo talking to us now.
Let's not give up and let's beat this. I know.
I'll have to look at that again.
Surprisingly, amazingly, they're still determined to keep that promise and keep going and, find the cure, find the treatment. They weren't able to do it in time for Mo, but they'll do it for other children.
Okay.
There we go. And what do you think this is?
DNA.
As a family, there's a lot of readjusting to do, and we're still a little bit lost.
Cut the DNA, and now...
I guess the comfort you get is that it wasn't all done in vain.
Because of Massimo, we've gone on to identify another 30 patients around the world with his exact condition. We've now taken the number of undiagnosed leukodystrophies from 50% back in 2013 to less than 20%, all being resolved within 4 months instead of 5 years.
So, he's made a huge contribution for a 9-year-old. Huge contribution.
The red thing isn't meant to be there. There's meant to be a blue one.
A blue and a red, that's right. We've just come such a long way. It just wouldn't be right to stop and say, that's it. Massimo's legacy is going to be about curing the condition he had. We owe it to Massimo to finish the mission that he started.